Hi everyone, hello, welcome. Let's go ahead and get started. First, just some kind of announcements / reminders since we're still getting used to things. Last week was actually a little bit different since we weren't able to have lecture due to the holiday. So this week is really kind of the first time that we get to sort of have the first full experience, I guess, of how we sort of hope things to go, how we hope the rhythm of the semester to go. The first homework assignment, as I hope you're aware, is already out, so you can see all the instructions for that on the course website. It is due on either Wednesday or Thursday, depending on which section of lab you're signed up for. You can turn that in during office hours. So we have office hours, they're already started. So every Sunday through Thursday, and also during the day on Friday. We have TA office hours, and then I'm also available for office hours. You can demo there as well. So you have plenty of options as to where to get help and turn in your homework assignment. Any questions about sort of logistics or stuff that's coming up before we hop into today's material? Any questions about assignment 1? Anything coming up later this week? Anything like that? Okay. Cool. So I hope that you had a chance to at least take a look at some of the coding exercises that were in the textbook today. I sort of have some notes as to which ones that I would like to take a look at, but I probably won't have time to look at every single one. So, you know, this isn't meant to be a complete comprehensive review of every single possible thing that is in the textbook. You are, you know, responsible for taking a look at that on your own, and this time I'm hoping we can use to, yes, review the basics, but also make sure that you get any questions answered that you have about stuff that you found confusing during the as you were reviewing the prep materials, as you were reviewing the materials and the exercises. So I'm just going to go ahead and get started by going through each section kind of one at a time, although I'm actually going to probably skip one or two as we go through. As I said, just due to lack of time, if I skip something you really wanted to see, shoot up your hand. Let me know. I'm open to doing anything, and I'll probably go off on tangents and do stuff that's off the beaten path as we go along as well. So please don't hesitate to shout at me, interrupt me, or take me in a different direction as we go along. But I'm going to start off by sort of reintroducing this idea that we have variables, specifically Boolean variables. So if I look at this line right here, line number 7 on this example, which is called test raining. What are the computer science terms for what's happening on that line? What would I say is happening? Anybody? Yeah. I'm initializing a variable, yeah. I'm also declaring it. I would have accepted that as well. I'm doing both of those things. They're technically separate, but we oftentimes see them all put together in one single line, like this. So I'm declaring and initializing a variable. This variable is a Boolean variable, so there's only 2 possible values that we could expect it to have, either true or false. And then the first main topic that we want to introduce to you this week is called the if statement. The if statement allows us to provide choice. So we now have the option to do something or not do something, depending on certain conditions present in our code. So the decision whether or not we do something is dependent on what's inside of the parentheses. So anything that goes inside of this parentheses has to be a Boolean statement. So that could just be a single variable. That's what we have here, right? A single Boolean variable. But it doesn't have to be that. It could be something more complex. In fact, oftentimes it probably will be something a bit more complex than just a Boolean variable. I could also, if I really wanted to, this is perhaps a little bit unusual, I could just type in the word true or false, right? Those are Boolean values. So anything that will evaluate to either true or false is fair game to go inside of those parentheses. We'll see some more complicated examples later. For now, we'll just take a look at what we've got here. So if I run this program, we'll see that since it's currently set to be true, it will tell me to go ahead and take the umbrella and then print out the message down at the bottom. I think what's important to recognize here, and what some people can kind of gloss over as they're learning about these if statements is that, it doesn't stop, right? We keep going. So if there's more stuff to do after the if statement, then we're going to keep doing it, right? The if statement isn't the end of the program. It's just an option. It's just a fork in the road. So if we switch this to be false, we'll see that it'll still do part of the program. It's just not going to do all of it because the condition in the if statement evaluated to be false this time. So we just skipped over this block and jumped down to whatever comes afterwards. So for an if statement, we have the word if followed by parentheses. One common mistake that I see here, people want to put semicolons here. Don't do that. That'll cause all kinds of weird problems. Instead, what do we see after the parentheses? What are these called? Curly braces? Curly braces? Yeah. It's a new symbol that you probably haven't used a whole heck of a lot before you got to this class. But that's what those are. And then we can have, as many statements as we want in between. Any questions so far before I hop into some more complicated examples? Yeah.
So does it have to be true for it to happen, or can you do something if it's false?
Yeah, that's a great question. Does it have to be true for it to happen, or can we do something if it's false? So we can do something if it's false, but in order for us to perform, whatever action is inside of here, we're typically looking for a statement that evaluates to be true, right? If I was looking for the opposite, if I wanted to know if something could be false, I actually have a way of flipping Boolean things, right? This is perfectly valid, right? So the way I would say this in English is, if it is not raining, take an umbrella. That's kind of silly. That's not really the intention, but it's still a valid statement as far as computer science goes, right? And it can be useful to phrase things that way sometimes. But let's take a look at something a little bit more complex. And we'll revisit your question of what do we do if it's false a little bit later on. More often than not, we're not going to know what the value is that is being evaluated. That's kind of I see an if statement as asking a question, right? I'm checking on something. I'm looking at the state of my program, the state of the little world that my program is operating in, and if it meets certain conditions, I'm going to do one thing, and if it doesn't, then I'm not. So I'm really kind of asking a question here. If it is cold outside, I want you to do these things, and this does some of the common mistakes that I see students do when they're working with if statements. I want to show you what happens actually if we try to run this program with these mistakes in here. We can see that instead of specifying true or false, we're going to use the scanner this time. Scanners can do Booleans and all kinds of things. You've probably seen that for yourself if you have started on the first homework assignment, for example. If I type in true here, it appears to me that the intent of this program is to tell you to wear a coat and to wear gloves, right? But in fact, okay, it looks like it does in fact do that. Let's see what it does if it does the opposite. False. Oh, it still tells me to wear a coat and wear gloves. That's all because of this pesky little semicolon here. What is a semicolon for? What does a semicolon do? It's the end of a statement, the end of a line. It's like the period at the end of a sentence, right? So when you put a semicolon here, you're actually telling the computer, check this condition, and then the if statement's over. There's nothing else for you to do here. Let's go on to the next thing now. Well, that's not really what we meant, right? We meant, all right, if this statement is true, then do this stuff. We didn't want a semicolon. We actually wanted a curly braces around those statements. Do you see what I did? Hopefully, to make that more clear with our intentions. And so now we can run this again. And hopefully see that it still tells us what we want in the case of a cold day, but if it happens to not be cold, then nothing appears, right? Nothing appears. It skipped it. It just jumped over everything. And there was no other instructions as to what to do, so the computer didn't do anything. It just said, okay, I must be done. Any questions on that one before we move on to the next example? Try to remember to look up at the balcony too. I forget it's up there sometimes. Yeah, question.
Yeah, so when you just type in like the name of the Boolean variable, it will check for a true value. And if you want to check for a false value, you have to modify it.
Yeah, if you want to check for a false value instead, I would do that by inserting an exclamation point out in front, which has the effect of flipping the Boolean value. If it was true, it's now false. If it was false, it's now true. So if you think about that, if this variable is false, I then flip it to be true, and so that says do everything that's in here. Right? Cool. Good question. Okay. Let's take a look at one more example, this time using numbers, because I think, using Boolean variables is actually pretty common. We're going to see it in other examples, but using numbers to do these kinds of comparisons as part of your if statements is actually, I would say, even more common still. So let's take a look at a more concrete example. And actually, we're going to take a little detour to start out. This is actually a review of something we covered last week. So if you reviewed the Module 1 material or the video that I posted from last semester, since we weren't able to have lecture last week, hopefully you got a little taste of this. But let's talk about random numbers for a second. I see a statement that says that this is going to generate a random number from -10 up to +10, right? And actually, we can take this one step farther. I want to be able to generate random numbers between any range that I want, right? I want to be able to say from whatever the lowest number is that I want to the highest number that I want, right? So how do we do that? How do we generate random numbers that can accommodate whatever range that we want? Well, let's see if we can break this statement down and try to figure out how it's actually accomplishing this. We're going to start here with math.random. What kind of value does math.random give to me? If I run math.random, a double, I like that answer. Okay. Yes, it is a double. Can we get any more information about the value that math.random is going to give? Between 0 and 1. Yeah, I like that. So I get a double value between 0 and 1. Okay. So what I like to do in these kinds of situations is assume 0 and then figure out what's going to happen, and then assume 1 and then figure out what's going to happen. Although we have to be a little bit careful because it's not exactly 1, right? It's exclusive, so 0.99999 repeating. So you do have to remember that little fact as you're figuring out the range. But if it's 0, this term quite clearly becomes 0, and then I subtract 10. So that has the effect of getting me to the bottom range of -10. This takes care of converting it from a double, which is what math.random will give to me, to an integer, which if I, am okay with having decimal values, I don't have to do that. I can just leave it as a double if I want to, but in this case, we're looking for integers. If I substitute in 1 here, so now I have not including 1, but almost 1, so this will be almost 21, right? A little bit less than 21 at its maximum for that term. -10 would be a little bit less than 11. And then when it casts that to an int, remember, ints don't round, they truncate, they chop off. So if it's a little bit less than 11, that means it's 10 point something something something. The largest value that it's going to be able to get is 10. And if I get a value between 0 and 1, then it's going to be a value between -10 and +10. We're actually using multiplication to expand the range, right, of random values that we get. And then we're either adding or subtracting to offset the values by a certain amount. Yes?
Now, won't the odds of getting 10 be artificially higher? Like it won't be equal? Because any number above? Like because you're multiplying by 21?
There may be an by one error. I think I understand what you're asking. There may be an off by one error here. Think about that.
Because let's say you apply like a number that's almost 1 by 21 and then subtract 10. A decent amount of the time, you'll get a number over 10, and then the int rounds it down to 10, right?
Yeah, but it's never going to round up. So if we don't include numbers over 10, then we never get 10. So we have to include numbers over 10. It's necessary. Question?
Is it possible for math.random to give you 1, like exactly 1? Okay.
No. That's what we mean by exclusive, yeah. Certainly easier to use 1 than 0.999 when doing arithmetic in your head. You just have to remember that it's actually slightly less than that. Yes? So the double data type will give you as many decimals as it can. So it's a lot, which I know is not an exact answer to your question, but it will actually vary depending on the accuracy, and it's a very, I think, cool discussion, but not one for this class. Take some upper level comp sci classes or come to my office hours. Yeah. Any other questions about random number generation before we switch back to if state, or actually, I mean, if we want to wrap this up, so I want to generalize this, right? If I want to get from, you know, low to high, right? If I have a lower bound to random to upper bound, how can I do that? Well, it's going to be math.random. Oh my gosh, Eclipse does not like me typing not code things in. Okay, here we go. Should put these in comments. There we go. Whatever range I want, it's going to be math.random times, it's the range, which is really just, you know, upper minus lower, right? That's the range of values that I'm trying to generate. And then you'll add the lower bound again, which has the effect of shifting it, right? If your lower bound is negative, it's going to shift the whole range down. If your lower bound is positive, it's going to shift the whole range up. Do you see that? And then from here, you can decide to either cast it to an integer or not, depending on whether you want your random values to be integers or not. Yes?
When it says upper minus lower, would you have to add 1 to that?
I think you're right. Yeah, you would have to add 1 to that. That's that actually matches up with this value here too. Yeah. So this is a great little formula to know. In fact, I mean, it's not entirely outside the realm of possibility that you'll be asked to generate random numbers on an exam coming up, for example. So back to if statements. After we've generated a particular random value, you can see that we asked some questions about it. So this, I really like how the comments here clearly illustrate that if statements are asking questions, right? Is this a positive number? Is the number greater than 0? If it is, then I'll say that. Is it 0? Right? If it is, then I'll say that. And there's sort of an implied third outcome that's not covered in this particular situation, right? Maybe they just don't, maybe the author of this particular program didn't care. But, you know, if we wanted to, we certainly could put in a third check that says if the number is less than 0, we'll indicate that, excuse me, that it's negative. What's this operation called right here? Ah, I heard it. Concatenation. Good. It's a lot of vocabulary words, especially early on, to get used to. Yep. Okay. So this will work if we, if we run the program a few times. We'll see that it generates random values for us. The number is 9. 9 is positive. That's true. I agree. And we can keep doing this a few times. Hopefully we'll get some negative values eventually. maybe. Okay. Might have to be a little bit, okay. I need to go to the casino after this. Wow. Really? Did I mess up my, okay, there, finally. Yeah, got a -1. Cool. I'm not gonna keep trying to get 0. That would take a long time, possibly. But yeah. One thing that I hope that you do notice, though, about this particular situation is that actually, so the way that this is written, I have 3 questions that I'm asking about every single number, right? So I'm picking a random value between -10 and +10, and then for each value that I've chosen, I'm asking, is this positive? Is this 0? Is this negative? Let's say it is positive. Let's say I pick 5, right? I'm asking, is this positive? And then I might say, yeah, it is positive. I'm still asking, is it negative? Or I'm still asking, rather, 0 first, right? I'm still saying, is it 0 and is it negative afterwards, right? And answering no each time. But we know that it's not actually possible for it to be anything, other than positive once I've made that determination, right? It can't be both positive and negative. That's not possible. So this is actually pretty common. It'd be nice if there was a way that we could chain these together, chain these particular if statements together to represent the fact that they are in fact connected. They do in fact represent one particular set of conditions. And we can in fact do that. I'm actually going to kind of jump around a little bit to this one, which looks very similar to the one we were just looking at, except it doesn't have the random number generation at the top. You can see that it first checks to see if x is negative, and then instead of having a second if statement, we have something a little bit different. This is called an else if statement. So we're actually chaining this to the if statement above. This is not a separate if statement. It is an additional condition, right? But we're only going to check this condition if this one is false. So if I look at the number and I've determined that it's negative, then I'm not even going to bother looking at the rest of them. I'm just going to say, forget it. I know what it is. I'm done, right? So the prior example, I had 3 questions, right? And it was possible that I could have, yes to all of them or no or some combination of. But in this particular setup, I'm just looking for the first one that evaluates to be true, and then I'm done. I'm out. Yes?
Can I put multiple else if statements behind one or two?
Yes, absolutely you can. 100% you can. In fact, if I scroll down a little bit here, you'll see a new situation with just else by itself. So there's actually a few different ways you can do it. The question that was asked before was, can I have multiple else if statements together? And you can. You absolutely can. I could say, this is redundant because I already asked it up here. Or no, I didn't. But yeah, you can chain together as many else ifs as you want. That's totally okay. But if we go back to the way this was originally written as an else statement, I want you to notice that unlike the if and unlike the else if, an else statement does not have a condition. Or what I would probably more accurately say is that the condition is implied, right? The condition down here is that it has failed all of the other ones that have come before it. So this is false and this is false. So the implied condition here is that x is negative or positive, sorry. But we don't have to say that. The fact that it failed the other 2 conditions has already made that determination for us. So we don't have to actually say that, right? Else is sort of a catch-all. If none of the other conditions that I've tried work, then I'm just going to do this thing. Any questions about else's or else ifs? So else's are optional. You don't have to have them. We've seen ifs without else's. We've seen ifs without else ifs. You can have an if statement with an else if with no else on it. What I want you to understand is that if you chain if statements together like this, you're going to pick exactly one option, right? If else is on there, You're going to pick exactly one option. You're always going to be doing one of those things, whichever one you find first. So the order that you specify those conditions actually matters. If you have any conditions that are overlapping, in this particular case, our conditions are not overlapping at all, right? But if you imagine a scenario where, I did have overlapping conditions, then the order that you place them matters. If this is, x is greater than or equal to 0, right? Well, now I've basically clobbered this else statement because it's overlapped. So the order actually matters, right? The order you write these things does matter. You have to be a little bit careful about the way you structure if and else if statements. Any other questions before yes?
If they do overlap, it's only the first one that gets run, right?
That's correct. So if, again, regardless of what the conditions are, if I have a set of if statements followed by else if statements, so it really depends on whether or not there's an else present. If there's an else present at the very end, then I'm guaranteed to do one of those options, right? Exactly one, whichever one I find first. That's how to evaluate it. So start at the top and just keep going until you find one that's true. Eventually you'll hit the else at the bottom. If there is no else at the bottom, then you don't have to do anything. You can just skip the entire if statement and not do any of the options that are present. That's the other application. But you'll never do more than one option. If they're chained together like this, the only way you can do more than one is if they're distinctly separate if statements like we saw in that original example. Right? I hope that makes sense, what I'm talking about. Any other questions? So one thing that you can do and can be useful to do is you can actually have if statements inside of if statements. Yeah. So something like this. But you have to be a little bit careful about how you do it. So this is actually called, this has a special name that's called the dangling else. The question is, which if statement is this else attached to? It's a little hard to tell. There's nothing in the code that's really saying specifically which one this is attached to, just from looking at this. I personally have a big problem with the way that this code is written. It is technically okay to write an if statement without using curly braces, but I personally never, ever, ever, never, ever write an if statement, or a loop for that matter, which we're going to talk about in a little bit, without using curly braces. So I think the biggest issue here is that whoever wrote this did not remember to include the curly braces. It's, I don't want to try and determine what their intent is, but depending on where we put the curly braces actually has an effect on where this else statement ends up going, right? So if I put the curly brace there, then it's attached sort of on the inside. But if I wanted to, I could actually include another curly brace here, which actually would kick it out and attach it to this if statement up top. Do you see that? Or, does this curly brace go down here? Like this? Regardless of where you decide to put it, I actually don't know that it matters too much in this particular example. I'm more concerned about showing you that it's very confusing to use these things without including the curly brackets. So that's really the point I'm trying to make. Use curly brackets. Always, always, always. If you ask me a question and I see you using if statements without curly brackets, I'm going to ask you to put them in. It just makes it easier to understand what's going on in your code, what belongs with which if statement. And then furthermore, pay attention to the indentation. That is not an accident, right? The fact that this is indented is very much intentional. we have a rule that you'll see appear over and over again. Anytime that you see a new curly brace, we're going to indent one more level on the next line. And then anytime you see a closing curly brace, we'll go back. And that keeps it nice and clean so that we can see exactly what's inside of this if statement, right? So it is not necessarily wrong to, leave out the indentation. In fact, the code that's up here now is 100% equivalent to, the way that I had it before, but I hope you would agree with me that doing it this way is not especially effective when it comes to understanding what's going on with this code. Right? This code will run exactly the same way, but there's one line that's like over here. So here's another great trick. I like showing this trick to people. If your indentation is screwed up, Eclipse can fix it for you. Eclipse can fix your indentation for you, which is nice. It will not tell you where to put the brackets. That's up to you. You have to put the brackets in first and make sure that the brackets are in the appropriate places. But once you are sure that you have the brackets in the right place, then Eclipse can fix your indentation for you. If you go to source and then, let's see, correct indentation right there. No, what did you do to me? I think you have to select all, like Control A, and then, there we go, beautiful. So yeah, Eclipse can help you out. Honestly, I think it's easier to keep it nice as you go. I would encourage you to do it that way, but if you find yourself looking at a mess, that's always an option. What questions do we have? Anybody got any questions? Cool. Then, let's take a look at some compound conditions next. So we actually introduced these a little bit in Studio. These symbols right here allow us to take two Boolean expressions, two Boolean statements, and combine them together. So these ampersand symbols, notice that there's two of them. If you forget and you only put one, that is actually something completely different that we're not going to really cover in this class. Although if you take 132, the follow-up, you'll find out what this one does. So in this class, it's always double ampersand, and I would actually just say that as the English word and. This code is very clearly written. You can see that they chose very good variable names for these variables. If you cleaned your room and you did your homework. This one hits close to home. I have a 12-year-old at home. Getting her to do homework is like impossible. But yeah, if you cleaned your room and did your homework, then you can go out. Like I would. The computer's going to evaluate that much as I would express it in English. Both of these things have to be true in order for this entire thing to be considered a true statement. Yes.
Did you put the exclamation point about one of the variables in order? Does that mean that it has to be false for it to have a
Correct, yeah. So the question was about adding the exclamation point in. That's correct. If I add an exclamation point in front of this one, then I would actually, again, I always very much try to read these out in English. If you cleaned your room and you did not do your homework, right? The exclamation point being not. So just flip it. Then you can go out, right? That's what this statement is saying. So yeah, you can use exclamation points to flip things to imply the opposite if you want to. You can also write this in other ways, right? There's other ways that you can write this statement that would lead to the same outcome, but this one is written in a very clear and easy to understand way, and that's kind of the tricky part, right? It's that's the part that takes practice, choosing good variable names and writing it very straightforward, very clearly. So one thing that I wanted to be sure to show you, everybody should know this. I'm not a big fan of like telling people they should straight memorize stuff. I think, your brains are capable of much more than just remembering things, but this is actually something that is very useful to just remember. You're going to use it all semester long, in fact, for the entire rest of your computing career. The truth table is what it's called. So this AND operation is what I would call this. It's called a logical operation, AND operation. There's two variables involved, but they're both Boolean variables, so they can both either be true or false, which means that there's only 4 possible ways that this can go, right? They can both be true, they can both be false, or one and the other. There's only 4 possible ways that so we can actually specify what all of the possible outcomes are, and I think it's useful to do so, right? So I'm going to abbreviate just because I don't have all the space in the world. So, cleaned room and did homework are the 2 variable names. True, true. True, false. False, true. And then false, false. Oops. So, I'm using the variables from this example, but really it's like replace it with any 2 Boolean variables, right? It doesn't matter. Variable 1 and variable 2. So what's the outcome? Well, the AND operation says that the outcome's only going to be true if both variables are true. So if either one of them is false, then the outcome is false. So the rest of the truth table looks like this. Only if both of them are true will an AND give me a true result back. It makes it kind of nice. Actually, we'll take shortcuts. The computer will too. If I look at this first variable and I see that it's false, I'm not even going to bother checking this one, right? I already know what the answer is for an AND operation, right? Not even going to bother checking. There's another complementary one called OR.